Thank you, Stephanie, for the nice introduction. And indeed, I will present some results of our recent study about barriers and levers to the deployment of heat storage in industry. And at first, which is quite, we are an industrial alliance created in 2018 to bring together all the players from the value chain of industry, from solution providers to manufacturers with financiers and specifiers, utility providers, etc., etc., in order to support the development of an offer, but also to support manufacturers in accelerating their decarbonization. You can see below our areas of intervention, and energy storage, heat storage would be between energy efficiency and potentially integration of alternative energies if we include heat recovery, recovered heat in this area. We are funded mostly from our members. We are independent. And our activities are split in four main axes. The bigger one is the collective studies, production, and monitoring. We have around 10 studies every year about decarbonization pain points, technical points delivered to our community. And they are voted by our members. So that's the reason I've presented this. And so the members voted for a study on heat storage and barriers and levers, which is a message I wanted to point. We have some activities of coordination within the network and also promoting the decarbonization sector. So I've selected the content of the study that will be useful for this gathering. And just a few words about our funders also. There are competence centers in France, bridging the gap between R&D, research, and the industry. And they are specialized in one sector usually, and that's the reason they've created ALLICE, our structure, to break the silos and to enable industry decarbonization in a cross-sectoral way. So now the study that was conducted, the objective was to understand the dynamics, the potential of the heat storage market, to identify the industrial sectors relevant for it, and to propose economic levers and models to accelerate their adoption. We've had 4 phases, an update of the status of heat storage technologies, high temperature. I will come back on that. I have not detailed that part very much in this presentation because I believe you are well aware of this in this meeting. Also, the identification of industrial configurations economically viable with the power to heat option. And the part I will emphasize here are the identification of the most favorable processes and sectors, an estimation of the market, and the barriers and levers for the diffusion of these technologies in industry. So what is industrial heat storage? Very quickly, okay, so storing flow heat in a storage facility, whether it's sensible, latent, or chemical. At first, heat storage was designed to recover waste heat to optimize consumption. And this is what we can see here. Okay, we have a high-level scheme of an industrial process with a heat generator, a first unit operation at high temperature, where we can have waste heat, we can store that waste heat in thermal storage, and we can just reuse this waste heat for the same operation for potentially, especially if it's a batch. But we also have heat storage especially interesting for processes with asynchronous operating modes. So you can just transfer the heat from the thermal storage to a second operation. You can also use it for electricity generation, for off-site recovery, for domestic hot water production on site, etc. So that's the general case. And I would like to add the reason we have a new study, because we've had already a previous study that was more state-of-the-art of the technologies, and there are various studies in France, but also I'm sure in Europe. Was that, well, so there are studies, there has been studies in the past, but still there are only a few projects like demonstrators, few projects, but it's not an industrialization of the technologies as of now. So we wanted to focus on the levers and barriers, and it was voted by our members. So yeah, I've introduced the previous drawing also to share the scope of our study, where we've considered what we call high temperature heat storage. So it's above 150 degrees, because for lower temperature water storage, superheated water storage covers perfectly well the applications. And an intraday storage duration. We've excluded other long durations, seasonal durations, because that's a majority adapted to industrial processes. And we've also considered the coupling with a power-to-heat solution. So it can be here for the heat generation directly, where you have a heat storage via power-to-heat, or with the storage to generate an additional value. Okay. To carry out the studies, we've interviewed several players. We've interviewed 4 technology developers here, but also service companies, or either carrying out engineering, financing, or this association. This is a paper association, actually, and also manufacturers directly. Yeah, so I've put this slide actually on the technologies, but that would be the only one. Each technology has been described for the community in a topic sheet. I believe you have all the information in the TCP, or more or less, and it was not too detailed. But we have latent storage and sensitive storage. The most mature technologies are thermoclean water technology, as well as the steam accumulator for some cases, and also multi-tanks in molten salts. The arrows legend here can be a little bit disturbing. We've put yellow, but that's the more mature technologies, but they are at the roof, let's say, of their potential a little bit, while the green arrows are less mature but promising for the future. So that's emerging technologies. Then we wanted to give our members the potential, the most interesting industrial sectors. So coming from the interviews, it comes that the high temperature storage has an interest with batch operations, and especially when you have to manage a process discontinuity between continuous operations and batch operations, with the operating constraints usually found that are the need to control the operating conditions of the process, and the quality and the quantity of the recoverable heat flow. Based on these parameters, let's say, we've identified 3 sectors, 3 or 4 sectors interesting for thermal storage, high temperature thermal storage. So steel making and metal surface treatment, mostly because of the use of batch over there, mostly in batch. Firing and treatment of ceramics, as well as the brick and tile industries. So once we've done these preliminary steps, we've tried to quantify the market for high temperature heat storage. And we've made two market studies, one for excess heat and another one for power to heat for steam generation. How did we do that? We've used reference studies in France because we've separated the French potential market and the European one. The French potential market, we have a reference study by the ADEME, which is the French National Energy Agency. And actually, it has been it had an update in 2022, but the reference is this one, and as well as a French white certificates potential here that gave some figures about the addressable deposit or the addressable potential. And in Europe, we found only that study, industrial waste heat, dated from 2017. So it was our only reference here, but we've used it. I will comment on that later. And the methodology was just quite simple. So we have the potential for waste heat in industry. We have cutoff points above 150 degrees and for favorable sectors. And then we've translated it into a capex to be deployed. So yeah, my comment is that the two studies doesn't really match in terms of figures when we look at the French, the potential in France, where we have more than 100 terawatt per hours by the ADEME document that I'm very familiar with. And in the reference study, we have only 30 terawatt per hours identified in France. So this warning is considering the difficulty to get the accurate numbers. The idea was more to consider the orders of magnitude rather than the accuracy of the data itself. And so here you have the methodology summarized, but that was quite simple in the end. It's only on this slide. So waste heat was considered at 300 terawatt per hours, but we've adjusted it a little bit since it sounded like a prudent estimation. So for above 150 degrees, we worked with 200 terawatt per hours. From the experts interview as well as the white certificate report, they've mentioned that probably 10% of the waste heat is addressable. That leaves only 20 terawatt per hours, which is quite considerable. And if we consider only the sectors highlighted, that leaves us with 3 terawatt hours for the EU. Corresponding with an assumption of 300 storage cycles and a storage efficiency of 70%. It corresponds to 8 gigawatt hours of storage capacity as the market in Europe. I've put the French figures here if you are interested, but that's basically it. What the reference study gives, so about the European one, and it's here is those detailed figures, where we see that Germany has the greatest potential among the EU countries. And then it's followed by France, Italy, Spain, and the UK, with also a good potential above of high temperature, let's say, above 150 degrees. And you also have light by sector, by industrial sector, with iron and steel concentrating the majority of the waste heat, but also non-metallic mineral. And that's also the sectors where we've identified the most favorable operating profiles to set up storage systems. So that's it for the market potential, heat storage, considering waste heat. We've also considered power to heat because that sounds like a very promising lever for the future. So in France, we've based on two different studies here, again from the ADEME and CEREN, that is a statistical industrial center, statistical center about industry figures in France, and from a previous study also financed by ADEME that we've realized in 2022, and that one is publicly available. So if you are interested, feel free to download it from ALLICE website. For the EU, we've based our figures on the World Energy Outlook from 2022 from the IEA. And here we've considered the amount of heat in industry, the potential of this heat for hybridization or electrification. And afterwards, again, we deduced the capex to be deployed. And so the results of this methodology gives, if we take the IEA, yeah, okay, it's in French, source, it's 1,800 terawatt per hours, 50% used for steam production hypothesis, so it leaves us with this figure, and 50% can be electrified, which leaves us with 50% cannot be electrified, and that gives us a European potential for power to heat fuel substitution. So that's quite optimistic if we want to consider that for all this area, all this energy will be addressed via power to heat, but that's a potential. And based on a yearly use that gives 52 gigawatts of power. What we want to highlight, what we got from this market data is, and it will be interesting with the value chain comment later on. So if we consider capex costs as mentioned here, and an average cost by project between 500,000 kilo euros or 1.5 million, we can convert these heat needs into a billion euros and number of projects. But the key figures here is really that if you consider the addressable potential with power to heat, then you get 30 times more market and project. And so that's a very big difference here. And that's, again, that's with the hypothesis, that's the order of magnitude that is interesting. And we realize that, okay, so the potential for waste heat storage is still huge, 3 terawatt per hours, but it's limited. So power to heat potential is much bigger, much deeper. So that's the key message, let's say, with this market study. I would like maybe also, since we have some experts gathered here, to do a little sidestep, because I've learned recently that the German government had a law in application since November 2023, forcing the companies to provide the data about waste heat. And I believe this is a huge progress for our community, for industry decarbonization in general. So if you are not aware of that, you can look out. There's an Excel file you can download with all the data. I mean, probably it's since January this year that they're feeding the data, but so it's already complete when I've looked at it. So it's a good initiative, and I'm trying to promote it as well in France, but we'll see how it goes. And so coming back to the study, yeah, an important part of the study was really to understand the levers and barriers for high temperature thermal storage in industry to develop, and looking at the value chain was necessary. So a heat storage project depends of the typical value chain of any energy project development in industry, where usually you have various players involved, so project developers, financiers, design offices, equipment manufacturers, etc. And you would have this project development stage with feasibility studies, financing, the engineering, procurement, and construction here, and the life of the project with operations, with maintenance. Here for heat storage, we have really the thermal storage component, and the critical components are the storage media, the heat transfer fluid, the control system that are left to the solution providers. But if we take the typical value chain, if we look at first project developers, they play a role to accelerate the standardization of the projects by controlling the project risks. And for heat storage, we have Enel that recently launched with this area. It should be followed by other energy service companies, but it's just starting. For the financing part, it is being deployed for the first projects launch. So we've highlighted few actors, few players here, but it's still slowly being deployed. Regarding the engineering, procurement, and construction, this is mostly done by solution providers today. We are aware of some engineering companies in France getting to these competences and market, but that's still minor. And the installation of equipments is mostly done by the solution provider for the engineering and procurement part, and by local companies for the civil engineering. And finally, operation and maintenance. So two things here. It's supposed to be of little constraint for heat storage systems and integrated by systems. But also on the other hand, we have for now too low volume of projects and installations. And so there are no players integrating this task as of now. At least not, it's not the majority of projects. And I would be interested to hear about your questions potentially about everything here. So, well, maybe a keynote here I forgot to mention here is that we see that the solution provider has a major role at several steps of the project still today, because this is an emerging market, and of course they have to take care that the thermal storage is correctly sized, etc., and they are critical in the project development and lifecycle. Just giving an overview of the market for solution providers, you can have three options now represented on the market. There is a design and license, where this is mostly R&D and develop the technology in the form of a license. You have the design and manufacture, where the solution provider, technology provider will design and produce the equipment as an equipment manufacturer. And you have the design and commercialization, where the player produces the technology, but also sells it directly to the customers and can even finance it in some cases. What we've noticed from the interviews also given to these to different stakeholders. Currently, the few projects launched in the industry are either marketed by solution providers with a direct contact with industrial, or by players in the energy or utility sector. And in that case, the solution technology provider is not directly in contact with industrial. And what has been highlighted from the studies and interviews is really that in both cases, the solution provider has a significant role in the project engineering, and it leads to two potential problems. So the solution providers first include engineering and design services in their offer in order to get some projects, which is clearly sounds reasonable, but still it will feed, let's say, the miscellaneous technologies, the variety of technologies, and therefore the engineering firms will have trouble to offer standard solutions and decrease their costs in developing these projects. On the other hand, solution providers can also market their technologies directly, and by doing so, bypass specifiers or engineering firms or even financing solutions, and in the end, discourage those players to position themselves, whereas those players could be a relay about the dissemination of technologies. So that's the two main barriers that we've seen with the value chain, which is normal for an emerging sector, but that probably needs to evolve to get industrialized. And we'll have, the conclusions and recommendations. I will conclude my presentation after these slides. So the conclusion of our study is, as said, few sectors really targeted, let's say, for heat storage, steel making, metal processing, ceramics production, and brick and tile production, with discontinuous unit operations. But with these cases, the market is a bit small and limits the emergence of really an industrialization of the sector. On the other hand, the market for thermal storage with power to heat for steam production gives a 30 times deeper market, and also, I've not mentioned it, but of course, a new source of revenue for projects with electricity grid services that you would provide to the electricity grid operators with the demand side flexibility. And another barrier, important barrier to the industrialization is the lack of a standard or standardization, holding back third parties. So again, the power to heat market which with its big size could encourage a dominant design and provide standardization of the designs. And last lever would be the financing levers, subsidies that you could get, for example, from carbon contract for difference. And I have like 4 recommendations out of the study. 2 recommendations to create a common culture first and stimulate industrialization. So these are some examples here from your feedback and thoughts about that. The working on common benchmarks for performance assessments, certification of the technologies, organized technology conferences, to support the creation of integrator networks. I know that this is already the case in the energy storage TCP. Last year it was in Lyon. Create information materials to provide training on the specific technical features of each solution. And in the end, also separate the roles of solution developers can be a lever to benefit from the integrators network implementation around Europe to increase this kind of projects development. The second axis would be to take some, here it will require to take some risks to lower the costs with the industrialization of the technology. But some ideas would be to industrialize solution with sharing design rules or developing common test benches. So find replicable applications such as power to heat, but there can be other examples, whether it's in a sector or etc. And create common technical standards and train independent auditors, which can be beneficial and can be an idea to implement here. And the two last recommendations axis would be to simplify the risk analysis for the project to get financed and generate the maximum value for a project. And I'm a bit long in timing, so I will just give few ideas. Propose a wide certificates sheet. For example, it has been done in France now since 1st of January. There is a wide certificate standard that includes power to it, about power to it actually, from waste heat. Develop a map of sources of waste heat to facilitate reuse, as we've seen with Germany, for example. We have it also in France actually, but it's not, there is no obligation from the companies to feed data, and therefore it's not well, it's not complete as of today. But definitely this could help to facilitate the reuse. And yeah, another idea could be to structure a guarantee fund between project developers or solution providers to promote the adoption of this technology. And so that's all the wrap up. We've had actually lots of ideas. I've tried to put to summarize them and to put the most important ones here, and would be happy to discuss them with you. Maybe shortly little advertisement for our third Congress that will be held in Paris on the 23rd and 24th of this year, of September this year. We really focus on manufacturers' feedback on decarbonization projects so that it can have an impact on the participants and really trigger new decarbonization projects. And you can find more information on the website. And briefly also, of course, you can subscribe to our newsletter. We have a trimestral newsletter. We have recently an e-cafe with a thematic every time. Last time it was waste heat recovery. The next one will be high temperature heat pump. So I'm not sure if you would be interested to participate, but it's just 1 hour exchange between experts and people working in this field, and it can create projects in the end which we want to develop. And thank you for listening.
Okay, so yeah, thank you very much for your presentation. Yeah, first of all, I'm very, very curious to look in more detail into everything. It seems like a very interesting work. I think Before we start with the questions from the audience, because I think there will be some, it's good that you mentioned also the waste heat platform, which is new in Germany. I also put it in the chat so people can directly connect. Just maybe a little disclaimer for everyone who will use it and cannot read German, which I can totally understand. It's important to understand that the Excel sheet is not, they're not all companies mentioned, because some of them are, I think it's around 20% missing, if I'm not wrong, but these are the ones with the highest waste heat in numbers. But they maybe will be added later, but because of, I think, some kind of, how is it called in English? Safety reasons, so they don't want to give too much details. They are not now part of the list, in case you wonder if the numbers are sometimes a bit different. But so I think it's a good thing as well. And yeah, I was quite happy that it exists now. I was waiting for it for a year.
Yeah, I'm waiting for it.
Yes.
Well, it exists, but there is no data in France. Well, there is data, but from the collectivities, only a few from industry.
Yes. So yeah, but at least some first steps are made. This is very good. Yes. And yeah, so now I go back to the audience. Are there any questions? Yes, Wim, please.
Yes, hi, Wim van Helden, AE Intec Austria. A very interesting presentation, thank you. One first question would be about the factor 30 that you mentioned between the different studies. Do you have any idea where the error is? Is it in both studies, or is it on reliability of data, or can you say something about this difference?
Yeah, so the factor is 3. The factor 30 is between, if you consider the market from waste heat and the market from power to heat. Maybe I misheard, but yeah. About the factor 3, to be honest, I'm not sure about from where it comes. Well, what I know is where it comes from, the French study, and it's data that is how do you call it? It's a form sent to all industrial to answer. It's a little bit like the feeding the data, but it's done like well, it was done in 2015, and so it gave the report in 2017, and it's based on an inquiry, like a form contacting all industrial players, and there can be some mistakes within these forms, etc., etc. I would say it's normal that there are some errors, but still that does not explain that it's a factor 3 with the other study. And I have not conducted directly the study, and I have not dig down in detail, so sadly I cannot really tell. I can give you the reference of the study, and I'm really looking for any other sources for any wasted data in Europe in general, because it was the only one, let's say, trustable that we found here, and that we could use.
Was it, if I may ask, was it the work from Mr. Tobias Fleiter? Because I think that they didn't look at all the industry sectors, but just a couple of them, the one with the highest demand. So it could be, maybe if you looked in France to all the industry sectors, that maybe this could be a bit of the variance at least.
The study should be this one. I've just Googled it.
Thank you. Okay.
But yeah, also let's say the French reference study is a matter of well, is questioned sometimes, because it comes from an inquiry sent to industrial, and it can contain some mistakes as well. So, but the idea is the orders of magnitude. And for the French study, there was an update 5 years after, and I believe 15 or maybe 20 terawatt hours were already addressed actually. So it leaves us with 90. But that was mainly actually for the wastewater treatment plants as well as data centers that were included in the study, but that were only a small part. And yeah, it can be the scope, but the idea is like if you measure it 5 years later and you see the difference, and the key message for us is like, okay, 15, 20 terawatt hours have been addressed, but still it leaves us with 90, which is huge, right?
Indeed,
That's
yes. Can I get one more remark then?
Sure.
Yes, yeah. Thanks also for your conclusions and for your recommendations, because this looks like, and it's also very familiar to what we are doing for large thermal energy storages for district heating. There's also lack of standardization, lack of knowledge with different stakeholders, and also lack of say a good demonstrator projects. So I guess that the list of recommendations reads as an IEA project in which a lot of experts come together from different countries and share their expertise and work towards these standards and new procedures and new ways of working. So perhaps this would be a good idea to bring this into the IEA Energy Storage Exco, and then see whether it's possible that several countries support this an initiative to have a new task on this.
yeah.
Yes.
I believe that would be really great, indeed.
Okay.
Yeah, I think, Wim, I fully agree with you. I just wanted to say, I didn't want to take too much time of the discussion. I wanted to leave it to the audience, but now you already mentioned it. There was last week already a task definition meeting on a new task, which is proposed, or will be proposed at the next Exco, which will deal with the let's say matchmaking more or less, and also understanding and demand from the application side. So this is very, very much in line what you did. There was no representative from France now, which doesn't have to mean anything. It's always a matter of time to get everyone involved. But if you want, I would love to be in contact with you as well about this task. It's still in the definition phase, and it would fit perfectly, to be honest. So it can be a good accelerator for your information as well.
Yeah, sure. What we do usually is we facilitate, and so I should hand over to a technology provider in France, but we are in contact with them, with most of them, so hopefully it will give something. Yeah, sure, with pleasure.
Good. So, do we have any more questions? Sorry, I was now talking too much as a host, so I want the audience to ask me.
Could be also reactions or remarks if you have any. Yeah, I did not follow the study personally. It was a colleague of mine, and so I've tried to catch up as best as I could. But so yeah, would be happy to discuss about the hypothesis or.
So as the audience maybe is thinking still about some remarks, I ask something. Now you have the recommendations, and how was, and it sounds like you were really directly in contact with the industry. How open did the industry seem in France to have the new technologies, and what was the main reason for them to hesitate? Like really was it security, or was it the capex they have to invest, or?
Yeah, so I did not participate to the interviews, but I can answer to that question with my because this is what we do usually, and I'm meeting frequently with these industrials, and so yes, they are very interested in any new technology that is mature enough to be installed on their site and enabling them to decarbonize. Heat storage is the case because we have probably you know of Ecotexeram in France that had already a few projects with industrial, and they start to say, well, there are already a few projects. We can maybe it could be a way to fulfill our targets. And yes, and mostly I would say that this is more potentially the price, the return on investment that is a big barrier, because industry in France, as probably in Europe, is not its shape, let's say, or it's not yeah, and so they still have to work with this idea, and that's probably the biggest barrier. But yeah, the fact that they've answered to the interviews, the fact that they voted for the studies, they are definitely interested within the technology. And there was no technical barriers mentioned. So yeah.
Yes. Okay, yeah. Well, it's nice to hear that the technical part would be kind of ready, but more or less, not with everything. But there is a lot which would be possible, but it's very often the problem now to get it really into the reality and yeah, have everything set. Yes.
Still, there are some projects, and I forgot, but at our Congress, there will be a presentation of the Kyoto Group project. I believe it's in Hungary with Geotherm, and it's 35 megawatt hours of storage, so it's a big one. If I'm not wrong, I need to double check, but that's a very big one, and so hopefully it will give some child projects.
Oh, sounds good. Okay, so do we now have any questions? Okay, I could ask a lot more, but I will feel like a quiz master, and I'm not sure if this is to go. Okay, so maybe I will ask one more if there is no one. So I saw the type of technology you considered for the thermal, the different thermal technologies. And as I'm working a little bit on PCM, so latent heat storages, I was curious to ask, did you also a little bit try to assess if there is maybe some demand of more research in different kind of thermal energy storage, like different PCM storages, or for example, also thermochemical ones?
And try to drill down in the report, but I believe it was more an overview of where is the technology now, who are the main actors, but also like the temperatures it can reach, an idea of the cost potentially, but that's sometimes difficult, and the operating parameters to take into account, and so I don't know.
Okay, yeah, so if they are too less commercialized already, this would be difficult to answer then, to give these parameters probably. Okay.
And it was really not the focus, because we've had a previous state-of-the-art study that was very detailed, but still we see that the projects are not multiplying as we thought it would. So yeah.
Yes. Okay, thank you. So maybe now we have a question I have to see. Okay, so there's a question from Jacob. He asked, you mentioned standardization as a way to reduce costs. Do you see a one-size-fits-all solution would fit with industry, or is the industry still fragmented in terms of temperature, heat rates, etc.?
So I will speak for myself, and yeah, I'm not an expert of all sectors, etc., but I would one thing I've learned from industry is that it's very difficult to have one standard. What I can recommend is maybe to, if you go for a project with metal making company, you can of course go to its competitors that uses the same processes, or actually of course go in the same within the same company and take care of the same unitary process, because you've gathered some feedback also from the first implementation, and since it worked on that case, it's probably the best option. Also, I believe federations and associations. I've learned that from the thermal solar energy federation, let's say. They work with federations of professionals to standardize this a little bit, like, let's say, to have a package or an advice from the association to its members. Like if you are the Association of Metal Making in France or in Europe, they can maybe discuss directly with heat storage technology providers and start with a layout, a framework of things to know and things to consider, and to help their members, which are manufacturers in the end, to contractualize and develop this project. So that could be an idea.
Thank you. There was another question from Ari. In terms of renewable perspectives, how about the possibility of the collaboration with geothermal energy, CSP, bioenergy in the future?
Well, bioenergy, geothermal, CSP, definitely. It's all as said before. It's more interesting when you have a batch operation or an asynchronicity between the process and the production of heat. So I would say yes for CSP for sure. And actually, we had the source of Solar Thermal World, that is a solar thermal website giving all the heat storage projects, and several of them, many of them were were combined with CSP or solar thermal in a way. So yes, for bioenergy and geothermal, I would be more cautious because as said, it's a continuous production. So I believe heat storage may not be as useful as for CSP.
So now we have a question from Nakin. I pronounce it right?
Yeah, hi. Can you hear me okay?
Yes.
Yeah, good. Thanks, sir. I missed the beginning of your presentation, so you might have answered this, but I'm really curious about policy interventions in this space. So when you do a lot of the calculations, especially at today's prices, a lot of these projects are not very feasible and are quite difficult it's quite difficult to convince industrial customers to use a lot of like heat storage and heating electrification. So I'm wondering in France, but also on the European level, whether you see any policies that are coming to maybe partially support this and like kind of kickstart this industry. And if not, then what kind of policy and what level of support do you think will be needed?
So your question is about the policies to support power to it and the demand side flexibility. Is that it?
Yeah,
or?
especially
Okay.
especially on the industrial side, flexibility measures.
Yeah. Well, since we've made a study about demand side flexibility in France, I know that we are pretty well armed, let's say, with these policies. It's well, the market is fully mature for demand-side flexibility. And for other countries, I'm not well aware. I know that France was very advanced, but also other countries have good policies supporting this. But it should develop. Not all the European countries. It's also an ADEME, which is a French energy agency, a study that gave this overview. And that is public, but it's in French. I can send you the link if you are interested. It's 2-3 years old, so.
Thanks. I was more curious about like the specific kinds of policy. Like, is it like a contract for difference?
Okay.
CapEx support? Is it or like technology
okay.
development? That's what I was curious about.
Yeah. Yeah. Okay. Yeah. But I've answered for demand side flexibility, and for this it's more markets, rules and regulations. For the other policies, we have the new white certificates sheet, standardized operations sheet, and I'm trying to work. We've had a study last year to benchmark all the policies, not all the policies, but for the most interesting countries in Europe, and to look out because, for example, CSP is not well known in France, and so not really subsidized. At least it's not written directly in the subsidies in France. And I'm saying, well, it is in Denmark or in Austria. I don't remember well, but it is. So it should be also included in France. I believe that there's some things we can do. I don't know your role, but we can do contacting the energy agency or the people to make the lines moves, because this technology has some. There is a project in Norway, there is a project in Hungary, or there are 5 projects in Austria. So I believe we have enough data to framework subsidy, but yeah, I'm not an expert of the topic. This is trying to make connections, but I'm looking a little far, not too much into the details of these subsidy programs. Hope it answers.